Hello and welcome to the 17th part of the tutorial on writing your own operating system. Now in the 17th tutorial I'm going to show you how to communicate with the network card that VirtualBox offers. So this is a device by, or a virtualized device by AMD. The chip AM79C973. Now, this is actually a relatively complicated device. I hope this doesn't take forever. Here in the code that I've prepared, it's about 7 pages long. So I'm a bit afraid that it will take quite some time. As I said, it's a quite complicated device, so there's a lot that we have to do. I want to show you this this site here on Low Level EU about the AMD PCnet. So this is where I've got a lot of the stuff that I've written here. Actually, there has been an error before. So when I wrote this for the first time, it didn't work, and it took me hours and I think even more than a day to find the error. I really had to go into the documentation of the actual chip and compare really every byte that was in the documentation with the code that I had, and then I really found that there had been a mistake. But don't worry, I've reported that mistake, and on the site it's been fixed by now. So I think a lot of the things that we are going to talk about are relatively familiar by now. I mean, we will make a class for this device, which will be derived from driver. It's going to also be derived from interrupt handler. We will get the interrupt number and the port numbers from the PCI. So this is the first time that we actually do something with the stuff we get from the PCI. I'm not looking forward to this. So the initialization of the device is really a lot of code. Sending and receiving data, it's not that much. Okay, so one thing that I want to talk about before we start is so this device can have multiple send and receive buffers. And for every of these buffers you need an instance of a structure which mainly has a pointer to that buffer. One problem with this is, this is one of these devices which apparently use some of the bits in the addresses for something else. So because of this, the index of the first byte of a buffer needs to be a multiple of 16. So, so I haven't found a solution for this problem that I really like. I think there was something along the lines of you can tell GCC that some data structure needs to be aligned like this or like that, but I'm not really sure about this. So the best solution that I've found is to just have 15 additional bytes. Then, so we will have a buffer of size 2 kilobytes, and actually we will reserve 2 kilobytes plus 15 bytes. And then we will use the first address plus 15 and kill the last 4 bits to get somewhere inside that 2 kilobytes plus 15 bytes. We will find one address that is a multiple of 16. Okay? So, yeah, not really a great solution, but as I've said, it's the best that I've found so far. So let's start coding. As I've said, it's a lot of code. So I don't want to talk about it too much, so that we get through this today. Okay. So I'm gonna include this in the PCI.h. So that in the PCI CPP we will be able to instantiate this. But the constructor will get this PCI device descriptor and the interrupt manager as parameters. Okay, so this driver is gonna be an interrupt handler. And it's gonna have a lot of ports. This time it's actually 16-bit ports. So we have 3 ports for reading the media access control address, the MAC address. So each of them gives us 2 bytes of the MAC address. Okay, so these 7 ports. Then it's also gonna have an instance of the structure initialization block, which I haven't defined yet. I'm gonna do that later. Okay. Yeah, and then I'm gonna have these 16-byte aligned buffers, 8 send buffers, 8 receive buffers. So 8 buffers of size 2 kilobytes plus these 15 for the alignment. Okay. Then I need some memory for these descriptors for the buffers. A problem with them is they also need to be 16-byte aligned. So I'm gonna just allocate some RAM here. And for the receive buffers, Okay. And then I will just move a pointer to a buffer descriptor into this memory. Okay. So these buffer descriptors look like this. Actually, I'm going to do this as a nested class or structure. So that the scope is unique. Okay. And attribute packed again. Okay. This is so much code. And this initialization block here looks like this. So we have 16 bits for a mode. I think with this we set it to 32-bit mode later. Oh no, actually this is for promiscuous mode. Okay. Then we have 4 reserved bits. Then the number of receive buffers and number of send buffers, which are 4 bits, and they actually define how many bits. So we will write a 3 in there, but that will mean that we have 8 buffers. Then we will have this the MAC address, I think. But this isn't actually 64 bits. It's treated like a 64-bit number later. But it's 48 bits. Okay, we had the physical address. Here's a logical address. I'm not sure, this might be for the IP address, but I'm not sure. On this level, we shouldn't actually be concerned about the IP address. And attribute packed again. Okay. Then we need a number which tells us which of these 8 receive and send buffers are currently active. Okay. Okay, from driver we will inherit these 2 methods and override them. And from the interrupt handler, we will inherit and override this handle interrupt method. Whew. Okay, we haven't done anything for sending and receiving actually, at least in the not in the interface here. But I want to get into the I want this to at least run at a point, and I want to initialize it. So now in the constructor, so we initialize this as an interrupt handler. So we pass the interrupt manager, and the interrupt number that we reserve for ourselves is what we get from the device descriptor. But this actually needs to be this must be increased by this offset that we used for the hardware interrupts. Like this, okay. And then we initialize these ports. So the port base is what we get from the PCI, this one. Okay, so I moved this out of here because I only want one driver for the device and not for every base address register. Okay, so the port address, the port base is what we get from there. Okay, the second. Okay. Offset 0, offset 2, offset 4. Then offset 16. Hexadecimal 10 is the register data port. Register address port is 18. Reset port is 20, and this is 22. Okay, when we want to reset, we just talk to the reset port. And after that, we should wait for 10 milliseconds. That's what this means. Okay. In the initialization, this is so much code. Okay. So in the constructor, I'm gonna read the MAC address. Okay, so we set the device to 32-bit mode. So we write 0x102 to the register number 20. I don't remember what this was. We set the stop bit. I think this might have to do with resetting. We tell it that it's not supposed to be reset now, I think. Okay, then we set the initialization block. So this means 8 buffers, because it's 2 to the 8, so the number of bits we use. Okay. Yeah, I think that should be correct. Okay, and now we do this, all this garbage with these buffers and their descriptors. So we move the pointer 15 bytes to the right, and then kill the last bits to move it to a 16-byte aligned address. Okay. and the same for receive buffers. Okay, terrible. Now, so now we've selected the memory for the descriptors, and now we have to set these descriptors. And here we basically have to do the same thing again. So with this, we send the length of the descriptor. And 7 zeros. Okay, so this tells it that it's a receive buffer and not a send buffer. Okay. So now we have constructed the initialization block, and now we move this initialization block into the device. Okay, so this should do the initialization. Yeah, I told you it's a lot of code. And we aren't actually even finished, so this is only in the constructor. Now in the activation method, so I think this enables the interrupts. Wait, why is this even supposed to work? So we read the fourth register and then we write it back, but we set the, I don't know, what is it, the 20th or something. I don't know, 12th, it's late, I'm a bit exhausted. We set one of the bits to 1. Okay. Okay, now in the handle interrupt, I think this is also necessary. I think this is similar to the programmable interrupt controller, where we have to read the data that we want to I mean, if it tells us that there is data, we need to fetch it. So now we read the register number 0. Now we cannot do a switch case statement because multiple of the bits might be set at the same time, because you might have different errors at the same time. So if we get hexadecimal 8000, this is just a general error. $2,000 is a collision error. $1,000 is a missed frame, so basically stuff like we get just too much data faster than we can handle it. So if we have missed a frame, that's the error code for that. So this is when we get data. And 200 is if it has successfully sent data. Not sure why this is down here in my code, but this says that the initialization is done. Okay, so this was a lot of code, and this is all just the initialization, you know. We haven't actually even sent or received anything. Okay, let's see if this compiles. Okay, this is a problem. So the device requires the PCI, and I tried to include the device in the PCI again so that the class definition was before the definition of peripheral component interconnect device driver descriptor. Okay, let's see, where do I put this? Well, since this is a mock-up, I think it's fair to put it here. You know, in the end, this isn't supposed to be hard-coded in it anyway. Okay, so nothing has happened now. Yeah, I mean the activate method isn't called, I think. Because down here I just instantiate the thing and don't add it to the driver manager. Okay, now I return it and add it to the driver manager. And then the driver manager, when I go into the driver manager activate all, it should call the activate method, and then we should get something. Oh great, it crashed. Hey, actually it has gone into the... I think I know what the problem is. I didn't return anything here. So then I probably return 0 or something instead, and then the stack pointer would be set to 0, and that would really cause such a problem. Let's see if it does work now. Okay, we have gotten some interrupt from the device. But it doesn't really say what the interrupt was, but I don't care. You know, this is really all I wanted to achieve today, because this is so much code. So this at least tells us that we successfully have initialized the device, we have activated it, and yeah, so I'm quite happy about that, even if I don't really know why it doesn't tell us anything more. It just says interrupt, but not which one, so whatever. I really think this is enough for today. A big step. We are now finally able to communicate with the network device. So, yeah, in the next video we will start sending data and receiving data, and then we will start building our network stack on top of that. You know, the Ethernet 2 frame, address resolution protocol, internet control message protocol, and all the other protocols, you know. But that's going to be a lot of code again too. Although, okay, I mean, IP, ICMP, UDP, ARP, Ethernet 2, they are all relatively simple compared to TCP. I can tell you that. We can get through that, but not today. This is enough for today. So, yeah, if you want to see the next video, just hit subscribe so you don't miss it. If you liked this video, hit like. Although I have to admit this was really a lot of tedious code, because it's just so much code we have to write. Not really much to understand before that. But, I mean, it is a relatively complicated device, you know, so what are you gonna do? This is just the way it is. So, yeah. Have fun with this, and see you next time. Bye.